हो गया, ठीक है।
Yes, sir. I'll give the introduction then.
So I need to, yes. Yes, sir. Give the introduction.
Okay. Okay. Hi guys. Welcome to Networkers Home Live YouTube channel. So today we have our senior trainer, that is Kundan sir. He is 15 years experienced. He will be taking over the session for static routing protocol. Yes, sir.
Yeah. Hi to everyone. Today, my session is the first part of the static routing. What are the options we have under static routing that we need to discuss today? Through all options we are discussing under static routing, we have three options. Let's see my diagram. Router 1, router 2, router 3. Three routers are there. Router 1 and router 2 having address of 170.16.12.0. And router 2 to 3, we have the IP address scheme that is 170.16.23.0. So obviously router 1 address is 12.1, router 2 address is 12.2, router 2 F01 interface address is 23.2, and router 3 F01 interface address is 23.3. And router 1 F00 MAC address is 1D, router 2 F00 MAC address is 2D, and router 2 F01 MAC address is 2E, and router 3 F01 MAC address is 3E. Now router 1 F01 interface, which is the gateway for host 1, it's having MAC address AA, and then IP is 10.1.1.100, and host 1 address is 10.1.1.1. Router 2 F01 MAC address is B and B, and then 20.2.2.100, which is the gateway for host 2, and host 2 address is 20.2.2.2. Same in router 3, if F00 interface towards host 3, which is the gateway for host 3, 30.3.3.3 is the 100 is the gateway, and CC is the MAC address, and router host 3, that is 33.3. Host 3 MAC address is 3A. Host 2 MAC address is 2A, and host 1 MAC address is 1A. Under static routing, we have the option of three ways to configure static routing. Through directly attached static route, using next hop address, and fully specified static route. When we are using option that is using next hop address, then router will do 2 times route lookup, that is called recursive route lookup, that creates it is utilizing router's processor more. When we are using directly attached static route, when we are mentioning next hop exit interface as my own gateway, in that case from where it is going to out from the destination to our destination, then it will follow the ARP procedure, and also it is going to follow that proxy ARP stuff. So understand here. On router 1, I've just configured static routing for 20.2 and 30.3. So 20.2.2.0, I have mentioned IP address of next hop router, that is 170.16.12.2. For 30.3.3.3, I have executed command, that is IP route, after that F00 interface, exit interface, that is source directly connected, though it is not directly connected to router 1, but that part we have executed here. So now, here we are not going to explain entire procedure, what is the packet flow, but actually what will happen when host 1 will try to ping host 2. Then definitely it is the rule of IP version 4. When host, our laptop or desktop system and routers interface try to execute ping command, they required destination MAC address. That procedure is called ARP procedure. Address resolution protocol is a procedure for mapping a dynamic IP address to permanent physical machine address. This physical machine address is also known as media access control MAC address. The job of ARP is essentially to translate 32-bit address to 48-bit address and vice versa. This is necessary because IP address in the IP version 4 are 32 bits, but MAC address are 48 bits. ARP works between layer 2 and layer 3 of the open system interconnection model OSI. The MAC address exists on layer 2 of the OSI model, the data link layer. The IP address exists on layer 3, the network layer. So first procedure which we are going to understand, when host 1 will try to ping host 2. First, it will generate ARP request. It doesn't consist the gateway because host 1 address is 10.1.1.1 and host 2 address is 20.2.2.2. So host 1 will generate ARP request for its gateway. The basic content of ARP remains, that is source IP, destination IP, source MAC, that is 1A. For destination MAC, it will broadcast the message, that is FFFF. It will receive by router 1 F01 interface. It will verify the source address. It is of my part, that is F01, it will send the reply. When host 1 will receive the reply of the ARP, then it will create layer 3 header as well as layer 2 header. So it's layer 3 header. When host 1 will try to ping host 2, so that is it will generate the echo. That header will consist like this information, that is source IP 10.1, destination IP 20.2, then protocol stub, that is ICMP for that one, and the TTL value, that is 255. Other headers are also there, just concentrate here. And then it will create layer 2 header. That will consist source MAC 1A and destination MAC, that's gateway, that is AA. That will receive by router 1 on F01 interface. First, it will verify the source content of its own MAC address is there. Then it will open layer 2 header, that is 20.2. So it is not connected on this particular interface. It will do the route lookup and submit the request on the buffer of F00 interface. So 2-time lookup it is going to conduct, that is first for F01, then F00. That is called recursive route procedure. We are going to understand this thing. Yes, Sarath?
Sorry to disturb. So from host 1 to host 2, you're going to ping using static route using the first method, right?
First
using
method.
The next hop information.
Next hop information, yes.
Okay.
So it would better for us to capture each and every link also, that what all information we are getting. So I'm going to capture this part, that is towards host 1. Then I'm going to capture router 1 F01 interface. And after that, I'm going to capture router 2 F00 interface. Now, first we are going to execute ping command and try to access host 1 to host 2. So first verify the show ARP. Host 1 doesn't consist gateway MAC address. So if you will execute ping command 20.2.2.2, first packet drop, second packet drop, third packet drop, and then we are getting that reply. When on router 1, if I will verify this command, show IP ceph 20.2.2.2, here we have the recursive procedure. All right. So now what output here we have when we have executed the ping command, that first on the host one part, that is it has generated the ARP request. That is the 1A source host 1 MAC address and destination MAC. It is 0. That is type of broadcast it has generated. And the second ARP. Now here it has the MAC address of A, it is gateway, that is 10.1.1.100 and 10.1.1.1. See the ICMP packet here. Type code, that is the ping request. That's why it is type consists type 8. Now we have the sequence number. Now these are the information we have here under the ICMP message type. On the router 1, if I'm going to capture this part here, what we have here, that is, it has received the ARP request. 1, it forwarded information. Target MAC address doesn't have. So it has second ARP request. Now it has all its forwarded its own information. And now this is the ICMP packet we have. Here we are finding. If we will verify this part here, that we have source address and destination address. Same information we will try to capture router 2 part, that here first it has 1D, its own MAC address, and the second ARP if we will be able to verify, that it has a 2D and 1D. 1D part of the router 1, it has received the broadcast, it asks is use my own information. So this procedure occurs when we are going to mention that IP address of next hop router. Any question in this?
Sir, one doubt. So in the first method, there will be a recursive lookup, but there will be no ARP entries. Is it? There will be no ARP entries using the first method.
ARP entries is fine, but basically that is that router does 2 type of lookup because it need to verify it. So ARP entry will come into picture when we'll mention that part. When host 1 will try to ping host 3, then it will generate the ARP request because it is F00 connected interface. So see here, when host 1 will try to ping host 3, now it has the gateway MAC address. So execute the ping command, that is 30.3.3.3. First time we were executing ping command, and now we have the reply. So when this request will receive by router 1, it is shows it is directly connected, but it doesn't have the MAC address of 30.3.3.3. So it will forward request towards router 2. That interface will receive the request, but what the target address is 30.3 and router 2, if this interface address is 12.2, ideally it should drop the request. But it will hold the particular request, what is getting request from the router 1, it will verify. Either it has the route for 30.3.3.3, it will find, okay, it is on the F01 interface. So it will inform router 1, if you want to get the access 30.3.3, use my MAC address. So here we are getting the proxy ARP concept. So once I am going to verify, that is router 1 ARP table. Now here you can see 30.3 or what the MAC address is 2D. So router 1 executed request on behalf of 30.3 using its own MAC address. So this procedure, actually when we are going to mention that, you can see here, so IP route static. Now 30.3.3.0 directly connected F00. Actually it is not directly connected, we have mentioned this path. So then it will forward the request. If you will try to capture again thing here, that on the router 2, if you will find the second request, see the second ARP, it allows it to use its own MAC address for 2D for 30.3.3.3. If I am going to disable proxy ARP concept here, that is not going to work. So on router 2, if on F01 interface, every interface by default proxy ARP remains enabled. That is so IP interface F01. Here what is written here? That proxy ARP is enabled. If I am going to use command interface F01 no IP proxy ARP, I have disabled this thing. So in that case, router 2 will not allow to use its own MAC address for 30.3 because it is not its own IP address. So now if I am going to execute again this ping command from router 1, definitely we will get the reply. So why I am getting the reply? The main question right now, this ARP cache entry is there. Once that ARP cache entry is going to disable, to verify this thing, best thing is that interface F00 set now it does its ARP entry has removed. Now try to ping 30.1.1.1. Now we have the unsuccessful because that request has been dropped, source unable to reach the destination. And if on router 1, if I will verify, so ARP, so this in router 1 consists of information. So do one thing, interface range of 00-1 first set, then no shut. Again generate this ping command and router 1 show ARP. It should show that is 3.3 should be remains here as is incomplete. Okay, sorry. I need to ping this address that is 30.3.3.3. Again, it shows that I need to clear first ARP cache entry from router 2 and router 3 everywhere. So best part I am doing there, just a minute. So this is the best way. Interface range F0/0-1 set this interface, and on router 3 interface range F00-1 and then set. Okay, no shut. So ARP. Now it will not receive the ARP. Now this ARP cache entry is going to remove, just verify from router 2. It doesn't have the ARP request for this 30.3 and router 1. It also consists. So if I'm going to use this command, clear it will take some time. So interface F00 set, interface F01 set, interface range F00-1 no shut. So what happened when proxy are going to remove? Now it will show us the incomplete. So now that's fine. After that you will get the desired output. So now it is not going to work because proxy ARP is disabled. If we are going to mention exit interface name and on under mid part, anywhere proxy is going to disable. So now we are getting this message 30.3. It should shows incomplete. Sometime we are not getting desired output. Should I remove this part also here? That is interface F00. Okay. Then interface range of 00-1 shut and no shut. Fine. So last, just execute ping command again. So what output we have on router 1? Now it shows incomplete. So proxy hop should remain enabled on each and every hop when it is going to, we are going to mention exit interface under static routing. So under static routing, best procedure to execute mention exit interface as well as IP address of next hop router that we have executed on router 3. See the router 3 routing table. So IP route static. Now here you have 20.2.0, that is 173.2 next address, that is routed to an own interface. For 10.1.1.0, same thing here. It doesn't require any proxy or concept, neither it is going to do the recursive route lookup. This is the best mechanism under we have static route. Is this fine? Why it shows incomplete? Because that proxy ARP is disabled. So on router 2, if you are going to enable that proxy ARP stuff, that is interface range F00-1 IP. Now that is going to work. So if again I am going to generate ping command from host 1. After some time, once that our procedure is going to enable, now we are getting the reply. So on router 1, see the hop table again here. It not incomplete. Now it has the MAC address of 2D. So ARP and proxy ARP, actually proxy ARP works when we are mentioning exit interface F00 and recursive route when we are mentioning IP address of next hop router. And if that is IP address of next hop router as well as exit interface. So from host 3, try to ping 10.1.1.1, we are getting the reply. So neither we have the ARP resolution nor we have the recursive route proxy ARP. So static route function, the third part of the static routing, we should adopt these features when we try to mention addresses, that the IP route destination address, what the prefixes of the destination address, then exit interface along with the IP address of next hop router. Any question in this part?
So the last method is using both the informations, right? The next
Both
hop.
the information, right? So neither we have the ARP, proxy ARP, nor we have the recursive route.
Okay. So I think this is the best method to configure a static route.
Yes, this is the best method and this is the desirable method which you need to execute in the practical life. Last method also we have here, that if I want to enable static routing, that is not recommended part actually. That on router 1, if I am executing command on global mode, IP route, suppose that is 30.3.3.0 is subnet marks, and then mentioning gateway itself, that is 170.16.23.3. It means now we are mentioning gateway 23.3 router 3 F01 interface. It is not directly connected with router 1. How many times a route lookup router will consist? If host 1 will try to access host 3, first route lookup occurs on the F01 interface, then F00 interface. After that, it will find how to come to get the access of 23.3. For that, it will submit request on 12.2, so 3 times route lookup. So this is called recursive route procedure under static routing. It is not mentioned, it is not recommended, we can apply this thing. So best path, IP route, destination address, then IP address of next hop router and own exit interface name. So this is the best procedure we should use when we are configuring a static routing. This is the first session we have for static routing. There we have discussed what the output we are getting when we are mentioning IP address of next hop router, then own exit interface, and then exit interface along with the IP address of next hop router. So that procedure we have under static routing. On the next class, that this recursive route procedure is not required. The next session of the static routing, we will discuss if we have the redundant path under static routing. What the advantage of each and every option, and then how to enable SLA so that if interface of the neighbor routers went down automatically, second route going to activate immediately. That part we will discuss. That is floating static route along with the IP SLA track command. Thank you.
Thank you, sir.
Welcome.